Well, I've added an interesting set of tools to my Nova Assistant. It's a research tools. So I've got a paper here. It could be any paper, but I've picked my own, which isn't published. A study on division methods in engineering and mathematical sciences. It's about using control systems to invert a matrix, basically. And, well, it's not that big, but it's got a whole load of examples and stuff. Now, the idea of this is that you can take any paper either as a URL or as a PDF, and you can read it into this new tool that I've got. So I'm going to read it in. So which one is the division paper? And what will happen is, first of all, this pops up. I'll explain in a minute. Paper tools. It's not like paper roses or anything like that. First of all, it will summarize that paper, and that's quite a good thing. So, any paper you don't understand it, maybe it'll summarize it for you. It'll condense it down. And then what I'm going to do is
summary. A study on division methods in engineering and mathematical sciences. Title: Study on Division Methods in Engineering and Mathematical Sciences. Author: T.G. Moir, School of Engineering, Computer and Mathematical Sciences.
So it's got a summary here of the paper, and it hasn't got a huge amount of equations in it because it's just a summary. It has got some. It's just written it in ordinary text. It's not written it in LaTeX. So it's got a few things there. Now, what I can do is I can say to it, extract algorithms, because in this is, well, I think I showed you the paper, didn't I? In the paper, it's got a number of algorithms in it, or examples. You can use, this can be either. If it doesn't actually have algorithms as such, it kind of takes examples. So it's called it algorithm 1. So I'm going to take algorithm 1, whatever that is, and implement the algorithm. So what it's going to do is it's going to write code about that. It's in the program itself that will be commented, hopefully. So it'll, in other words, try and replicate the results, because these results were found by computer simulation, actually on MATLAB, but this is going to do it on Python. So I'm not exactly sure which bit it's going to do, but if, for example, it's not accurate enough, I can put manually, I can feed in a query in here, tell it to do something. But it should actually be writing up a code at the moment. So where is it? Said implement algorithm, didn't I? There it goes. Actually, it did a search for some reason. Oh no, that's not a search. It's finished. Sorry. This would come on if it was a search. It's another beep I put in. Just that it's finished. That means it's finished doing its code. So here's the code here. It's just simulating. It's a very simple system. First order continuous time system. It's quite interesting. Yeah, so it's basically doing division by using negative feedback. It's all commented, so I'll have to look at the code and see if it runs. So it's got this idea from, well, it's the same example as I've run really, but in the continuous time case I didn't actually run an example. I did it in discrete time, but it's, I think I've done a continuous time. So all I need to do is remove any comments from here and it should run. He says, actually, that's quite nice. It's even got a little, drawn its own block diagram at the end. Something else I could put in this. Just have to delete all this stuff though. See, it's got this. Now I've got to get it there. Let's get rid of that. And that's in the beginning. Up here, let's see where the Python block is. That's these three let's get rid of them. We need to get rid of, oh sorry, it's here. We need to get rid of it from here, and that's the program. So let's run it and see if it works. Oh, wow! So what it's done is it's taken, it's just a very simple thing, this. It's taken 4, divided into 1 upon, it's getting the reciprocal of 4, 1 upon 4, which should be 0.25, and so it's converts up to 0.25, and here's the error going down to 0. So it's a control system that does division. Now this idea is being used in analog electronics for, I don't know, since the maybe 1950s or 40s, maybe even when we're using thermionic valves, is you in order to get division, you put a multiplier in the feed. Well, yeah, you put a multiplier in the feedback path. In order to get division, you get the opposite of it. So there it is. So what it's done is it's taken my idea straight from the paper here. I'll show you where it is. That's it there, that block diagram, and it's stuck it into code. And last time I could say Jack Robinson, there's the differential equation, and that's the convergence of it. And then I do the discrete time case, but I didn't even simulate it. But I knew it was working because I knew from the maths it would work.